everybody, I am Anirban and I am a junior researcher at Kanisha. Today I am going to present my own research paper, that is improvement in Cubesat communication using patch antenna. We all know that how Cubesats have played a great role in improvement of the space technology sector because they are cost effective, they have a small size and they have diverse uses. But 40% of the CubeSat missions fail due to one single thing, that is improper deployment of their antennas. CubeSats have, or all the satellites have two types of antennas, that is deployable and non-deployable. Most of the CubeSats that use the deployable antenna you are using the turnstile antenna. If we take this as a CubeSat and then we make the picture of a deployable antenna, then it is something like this. So first, the CubeSat is when it is in the deployment box or it is not deployed, then the antenna is inside the chamber and it is not deployed. After reaching the space, it will be deployed. But the problem comes here that everything on the mission is based on this. If this is correct, then the whole mission will be perfect. But if this goes wrong, then the whole mission is a waste. So this has to be perfect. But the problem comes here when this is improperly deployed. So the whole mission becomes a waste. But to a solution to this, we have a non-deployable antenna or a fixed antenna. That is a patch antenna. If we take this as a face, then a patch antenna covers this side of the face. And it is non-deployable, so it is completely fixed. But there is some problems in the patch antenna, that is they have many limitations. So my research paper is to improve the CubeSat communication using this patch antenna, so to reject the problems that come due to the improper deployment of the deployable antennas. So the question is, how can we do that? For this, I have taken some things that have came into my mind that we can improve about the CubeSat and its patch antenna. That is, we can control its orientation. Like we usually use the traditional three reaction wheels to control its orientation along the three axes, that is x-axis, y-axis and z-axis. We can also improve the material that are used to make the patch antenna. And we can also see that how the ionosphere and the onboard computer's EMI or electromagnetic interference affects the whole system, and we can eliminate that. So first, let's start with the material selection. For the patch of the patch antenna and the ground plane, we are considering to use borophene. So borophene actually it is a 2D material, and why are we considering it? Because of its different factors that we can use in the CubeSat's patch antenna. That is, first of all, it is very lightweight. Second, it has very high electric conductivity, and its conductivity is depend on how it is synthesized and how it can be modified. Because it is 2D, it can be modified in the labs to get better performances. It is resistant to space radiation, and also it is corrosion resistant. Then we will see how to make the substrate or what material can be used to make the substrate. So for the substrate, we will use EPP foam, that is expanded polypropylene foam. So why we are using it? Because of its properties. That is, it has a dielectric constant of approximately 1.03 to 1.05. Its loss tangent is close to 0.002 to 0.005, and it is very lightweight. So it will be perfect to make a lightweight system. Then we will see that what we can do with the orientation of the CubeSat and how can we manage it, the three reaction wheels while making it lightweight. So the traditional three reaction wheels are like this. It is something like this, where this is the motor and this is the reaction wheel, and there are three of them to control it in x-axis, y-axis, y-axis, and then z-axis. So this is what a traditional three reaction wheels looks like. But if I put this in the 1U CubeSat or a smaller version of the CubeSat, then it will take a lot of space, and plus it will be very heavy weighted, which is not good for this whole system. So we can change this by making this removing this reaction wheels and doing something like this. So for comparison, first we have taken a whole wheel, and for this, and in this modified version we are taking just a kind of rod and attaching two equal weights at the end. So this is more weighted and this will be less weighted. And now how the reaction wheel works, that is its working is based on the principle of conservation of angular momentum. When this reaction wheel rotates, then there is some momentum generated. So to conserve that momentum, the whole Cubesat body, if this is the Cubesat and this is the reaction wheel inside it, and if the reaction wheel moves in this side, then a angular momentum is generated, and to conserve that, the whole Cubesat body will move in this side, which is the opposite direction to the rotation of the reaction wheel. So the basic principle is conservation of angular momentum. So here we will use this system or this model of the reaction wheel, and we will attach the motor to it. And if we take like something for this the RPM or the velocity or speed, whatever we say, the for the this traditional reaction wheel, and if we take this, we will just have to increase this RPM or the velocity of this. So if its velocity is more, then the angular momentum will be generated more. Or basically we can say that if its basically its mass is less than this one, so to proportional as because it is directly proportional to the angular velocity, angular momentum actually, then if the mass is less, then the angular momentum will be less. So here the mass is less, the angular momentum is less. But one more thing is directly proportional to the angular momentum, that is the RPM or the velocity or the angular velocity of this rotation. So we will here using this motor, we will increase that angular velocity or the RPM of this reaction wheel. So because this RPM or the angular velocity will be more, then it will generate same or more based on the speed, same or more angular momentum, which will be conserved by the Cubesat, and it will rotate in the opposite side, basically giving the same results as this. But the advantage of this is we will have more space in the Cubesat body. Materials will be saved, like we are taking a whole wheel and here we are just taking some pieces of it. Materials are saved and it is very cost effective. We will talk about how the ionosphere affects this communication of the patch antenna in the Cubesat. So the Cubesat is basically placed in different orbits, like the lower Earth orbit (LEO), and maximum of the times the maximum satellites are placed in the ionosphere or just something just above it. So in the ionosphere, as the name suggests, ions are filled with it. So it gives many problems and many issues to the electrical things and the radio frequencies that reaches the satellites. So the effects that we can see due to the ionosphere are that scintillation, Faraday rotation of polarization, plasma noises are generated which disturbs the communication, and then refraction and loss of signals. So how to remove it? Like in a traditional way of removing it is by using higher frequency radio frequency, that is the X bands and the S bands to communicate. So this problems like scintillation will be removed. Now how to remove the plasma noise and the other problems? For plasma noise, we can basically do is we can use Faraday cages, and that will be installed inside the body of the Cubesat. So what will it do? It will not allow the plasma noises from outside the Cubesat body to enter inside and affect the onboard computers. Neither it will allow the electromagnetic interference from inside the onboard computers and inside the onboard system to go outside and affect something else, the other system or something else. And now one more technique that I have shared in my research paper is that by using noise cancellation techniques. That is, my method is inspired by the noise cancellation techniques that are often used in headphones and things like that for sound systems. So what is that? As we know that in sound cancellation techniques, what we do is that if there is any noise or any disturbance, we take the frequency, amplitude, qualities, waveform, the different qualities of the wave, and then we generate a counter wave for it. That is a wave that is totally opposite to it. And when these waves interact, they cancel each other out. So this is how the noise cancellation works. So this can be done, and this can be implemented in the CubeSats also. That we can do is, if there is any plasma noise coming outside from the outer space or outside of the CubeSat body, we can do is we can take all the informations from the CubeSat from the about the plasma noise or the electromagnetic interference EMI wave, and then we can generate a counter wave for it, or a wave that is totally of opposite nature. So this will interact with that wave and cancel each other out. So by this we can reduce or kind of eliminate the effects of the ionosphere. And for this we will have to use the ionosphere monitors also to monitor, to take data, and to do different things and to collect different information about the ionosphere. So by this I want to come to the conclusion of my research paper, is that how can we improve the CubeSat communication using patch antenna to reduce major mission failures, such as non-deployment of the antennas and many problems. So to improve the CubeSat, we can do we can we can do proper material selection. We can use borofin, and borofin is such a material that is being still researched on. So and whatever we have got the results from the research, it suggests that it can do many things if it is modified properly or synthesized properly. So for future we can do is we can dope it with different elements or different materials to increase its performance. And for substrate we are using the EPP foam. And for next then for the control and the orientation of the CubeSat along the 3 axis, we have introduced a different or new model of the 3 reaction wheel system, which will save the space and it will save space, save money, save material, and many things. So so this will be benefit for the CubeSat. And next we have seen that how can we eliminate and what are the problems of the ionosphere that affects the CubeSat communication or the satellites. So and how can we eliminate them? That is by using Faraday cages. Now here the Faraday cages needs to be of materials that are very lightweight. Faraday cages are of metals and that need to be very lightweight, or it will hinder the performance and become very problematic for the whole CubeSat body or the framework. And next we are talking about that we are talking about noise cancellation techniques. So as we have seen, we are generating counter wave to cancel out the plasma noise or EMI waves. And by this I want to conclude this. And for the future scope of this research on the topic is that we can take borofin and dope it with different materials, as I have already said, like carbon can be taken, and we have to see the different results with what it gives more efficiency. Then we can introduce AI to the orientation to control and orient the CubeSat body according to the 3 axis. Using the AI we can take the inputs of the inputs of the frequency that and the target ground station, the location of the different bodies, like where is the ground station on the earth, and the face or where the orientation, mainly the orientation of the CubeSats. So we will take the information of that and control the the AI will control it according to the what frequency it will need, or it can switch frequencies to give better performance in communication. And by this we will make the whole orientation of the CubeSat autonomous. Then let's come to the other thing, that is noise cancellation and the Faraday cages. So proper materials, more materials can be studied that are corrosion resistant and less weighted to make the Faraday cages, and the noise cancellation technique that we are using in space must be studied to get more proper results and improve that, and use it in the to use it to protect the satellites, antenna, and the other things that are important in the system. And the major thing that are taken in missions, that is the how is it cost efficient or not. So we can do things, or we can introduce methods, or we can do research on how to make these things or these research more cost efficient to do the overall thing better, so that we get more opportunities and more capital to do more things and more better things, and more systems can be given into the CubeSat. And by this I want to say that this is what I wanted to present in my
As you
research
have seen
paper.
this video till the end, that means you are interested in space and different things related to space. So subscribe this channel and let's meet in the next video.